Hey guys! Now, any chef worth his salt will tell you that the only way to cook an omelet is with a spatula. Huh? Today, we are talking about volcanoes and specifically how different types of fluids can affect the way that that volcano is going to erupt. So we have two things set up here. Now, in the first one, essentially what we have is a plaster mold. Now inside this mold we have some color crayons. Now these are basically just colored wax wrapped in a string that is also coated in wax. This little bundle of crayons is suspended about this far down in the plaster mold, and then the wax string has been cut at the top flush. What's going to happen is we are going to boil some water, place the plaster mold into the water. The wax is going to heat up, and what we're going to see is that because there is wax coating the string, that wax is going to melt and it's going to allow the magma to come out of the top and bubble out like a volcano would. And essentially this magma would represent best possible scenario with a really non-viscous fluid and something that would be allowed to escape rather easily. So that's what we're going to do with this one. The second example is something that we would hope to see with a high silica content magma, something that's highly viscous, and create more of a Mount St. Helens style eruption, to where the magma no longer, essentially what we have is the bundle of color crayons is embedded inside, but there is no string. So there's no mechanism for any degassing, any pressure release. So we're going to boil this one and heat it up and hopefully see an explosion. We'll find out. Now, the difference between the two types of fluids that we're looking at is essentially you've got Newtonian fluids and non-Newtonian fluids. A Newtonian fluid would be something like water. Takes the shape of whatever it's in. Fluid in the most traditional sense. Now, the other type of fluid is a non-Newtonian fluid, and we see that with something like cornstarch and water. Now, cornstarch would symbolize our silica content, Argo. So we really have here a perfect example of a non-Newtonian fluid. Water being our Newtonian fluid, traditional type of fluid. This cornstarch and water really is an awesome example. I mean, this is something that people do in elementary school and play with it, and they call it oobleck or whatever, but it's a non-Newtonian fluid, and what that means is essentially, as I pick this up and I kind of keep it under pressure, so I'm kneading it, right? The more pressure I exert on the fluid, the more it wants to resist. And the cornstarch being a great analog for silica content in magma. The cool part is that when I let it go, it just completely melts and turns back into a liquid. So this is what we're talking about when you've got a scenario where, scenario one, basically, ideal circumstances where the magma is very fluid-like, low silica content, basically what you would see like that very black basalt magma in Hawaii. And that's released very easily, and so you have these beautiful, very smooth lava flows, non-violent. That's what this is going to symbolize. map gas. While we're waiting, have you ever seen someone heat up drywall until it glows? This is not part of the experiment at all. I just thought it was cool. Check that out. That's awesome, right? All right, here we go. Finally. Had to boost it up a little bit with that map gas, but it's finally starting to bubble out. So what we're seeing is first the wax from the string, which is black. So looking at this wax that's coming out, it's not black. It's kind of got like a brownish tint to it. So I'm wondering if we are actually getting some of our magma. So I've kind of wiped it clean so we can see everything that's going on here, but it definitely is wax. So you know, experiment success essentially. And what's coming out of here it's actually 100% wax. It's just a lot more clear than I had hoped it would be, and less. So I've kind of wiped it off. You can see the new wax that's bubbling out, and it is wax for sure because it is the wax that I put in there because it's orange with a little bit of black mixed in. So as you can see, we are getting some of our magma coming out. It's bubbling out. Actually, if you look right here, this is interesting because the wax is, even though it's a bubble and there's air inside, what's happening is the wax is coming out of the crater and it's actually hardening, and this is basically what a dome is. That the gas that's escaping is filling up inside there. Now, even though it's not, you know, a crust and more magma, the magma is kind of going around the dome that's been created here. But we have an actual legitimate dome that's forming right there. See, there it goes right there. For this one, our little ball of wax is trapped about maybe a half an inch under the surface. Now, I just started heating this up, that's why my face is so close to it. What we may have to do here, because that last one took so long, heat this up a little bit. I doubt it's going to explode. You get the point. So this is going to be our super viscous, you know, non-Newtonian, high silica content. And basically, hopefully we can get some kind of reaction here. I'm going to speed this process along. Now, I have created a pretty high-tech face mask. Okay, we haven't exploded yet. Then the map gas, and by the way, you know, I'm not trying to steer our professor's hand here or anything. But I think I'll probably be the best experiment as far as, you know, high tech on a broom handle. And then I'm going to be back behind my shield with the eye flap. Okay, double protection. Oh, this is great. I feel really safe. I think I've got an even better idea. It stands back behind the plastic, and then, oh yeah, here we go. Oh, don't go out of control. I don't want to light the house on fire. It definitely burned my fingertips putting out that fire. Definitely burned them. I probably won't be able to type anything. It's fine. It's fine. I'm fine. No. Hold the door. it's gonna explode. So this is something I almost forgot to show earlier, but basically you just slice the mold there in half. And so this is where all the color crayons were, and then you see the channel going straight up the middle that the magma traveled through. So that's kind of cool. It's just a good example. I mean, obviously under normal circumstances this would all be like mantle down here, but kind of gives a cool little idea as to what was happening inside. So I thought that was worth throwing in there. So what did we learn today from this experiment? Couple things. We talked about viscosity of fluids. You get Newtonian fluid, non-Newtonian fluid. The idea that Newtonian fluids are going to flow a lot better. Create a Hawaiian-style volcano that's going to be a lot less explosive than something that has a high silica content. A second experiment that I did didn't work. So we also learned that experiments don't always work. Oh, don't go out of control. After looking a little bit more closely at the object, was that it was releasing too much pressure out of a crack that formed in the side, and it wasn't releasing the magma. It wasn't allowing the magma to build up pressure and blow up. So a lot of fun. So I hope that you guys enjoyed the video as much as I enjoyed making it. And if you have any questions about what I did here, okay. Thanks for watching.